Hello everyone, I welcome all of you for the third session of CAENexus basic training. Just a quick recap. So in earlier session we have seen some details related to abstract model authoring. So we have seen the classes, their closure entities, their relation, and we understood how exactly the simulation physics is getting transferred onto the geometrical entity. Now, in this session, we'll see productivity improvement tools in CAENexus. So we'll talk about some important features. We will see how one can validate the geometry before sending it to CAENexus workflow. And towards the end, we will see some details related to meshing and graphic tools. With this, let's start our session. So we'll first see some important features which will assist analysts and will save lot of their time. So the first is the CAENexus log files. CAENexus generates some log and the simlog files which includes some warnings or the error related to CAENexus process. So for example, CAD model.log or the simlog file, it records your non-manifold model creation process. Similarly, simulation model.log or the simlog file, it records attribute transfer process. So likewise, some logs and the simlog files, those are getting generated and it records some processes. So one can refer these log or the simlog file appropriately, and based on the error or the warning given in that, one can take a corresponding action. So this way, these log or the simlog files, they assist the analyst and analyst can just take the appropriate actions based on the warning or the errors highlighted in the log or the simlog files. Another feature is attribute conflict. So attribute conflict, it occurs when two attributes of same type, they are getting transferred onto the same geometrical entity. So for example, let's say I have one surface and to one attribute I am saying that I want to transfer a 5000 Newton load on that surface. But my another attribute of same type, if it is saying that I want to transfer a 10,000 Newton load, then it is a conflicting situation, because on the same geometrical entity or on the same geometrical surface, I am saying that I want two different loads, or I want two different loads with the different magnitude. So such situation can occur in CAENexus workflow, because in CAENexus we are setting up the physics on the abstract entities and not on the geometrical entities. Also, this attribute conflict is written in the log file attribute conflict.log, where it will highlight which are the two attributes which are having conflicting situation. Also, a error message pops up during that process highlighting there is a conflict between two attributes. Now, to resolve the conflict, there are two ways. So firstly, you can directly delete one of the attributes which you don't want, or you can just increase the precedence of one of the attribute which you want to be considered in the process. Again, the details about this attribute conflict is given in the tutorial, as well as we have a user guide which talks about our conflict policy. So you can refer that tutorial and user guide for more details about this attribute conflict. Another feature is CAENexus API mode. So with this mode, one can run the CAENexus workflow in a batch mode. So one can create a simple text file. So that text file will have details about your CAD model and abstract model file. With some simple Python script, you can run those multiple CAD models without any human intervention. So this is very useful in the production mode, and we have a dedicated tutorial for this API mode. So you can go through that for more details, and you will understand how one can run the multiple models without any human intervention. Another important feature is accessing parameters from CAD. So one can add the parameter in the CAD model, and the values against that parameter can be fetched in the CAENexus workflow. So for example, mesh size is the parameter which is added in the CAD model, and there are some different values given for that parameter against different CAD parts. So I want a different mesh sizes for different parts, so that I have specified in my CAD model under mesh size parameter. Now these values we can directly fetch in the CAENexus workflow. So for that I need to first create the attribute in my abstract model file, and in the attribute I have to use an expression called as double param from CAD. So in that expression I'll just specify the parameter name. So in this case it is a mesh size, and in case if I don't find the value against this parameter in the CAD, then what should be my default value? So that value I will specify in this expression. So once done with this, I can directly fetch the values in the CAENexus workflow. So you can see here, these are the mesh size values which are automatically fetched in my simulation model. So accessing CAD parameter is also one of the important feature. Another feature is reapplying your class or the component attribute. So with this functionality, you can just edit the values in your attribute from the class tab, and those values will get reflected into your model tab as well. So this is just for quickly editing your attribute. Please note that the changes made in the attribute will not get saved in your abstract model file. So these are some of the important features in CAENexus. Again, we have the dedicated tutorials available explaining all these features. So once we are done with the basic training, then please go through that tutorial so that you can understand how to use these features and apply it for your practical cases. Let's now see how one can validate the geometry before sending it to CAENexus workflow. So in installation directory, we have the CN model validity, and once we launch that, then you will see the user interface as shown here. So you can set appropriate criteria, for example, short edges, global interferences, some small features, etc. And based on these criteria, once you validate your CAD geometry, a validation report will get generated. So that report will highlight some warning of the error which are present in your CAD model, and based on those errors you can take necessary action and you can just update your CAD model. So this model validation will help you to get rid of some errors or the warnings which are present in your CAD model before sending it to CAENexus. Similarly, we provided some controls in the abstract model file. Sometimes small features or small faces, they create some bad quality mesh, and it's good to suppress those small features or small faces. For example, if this is my CAD geometry, and if there is a small feature or small face having a dimension of 0.05 mm, then it will create a bad quality mesh, that is skewed element it will create, and in such cases it's good to suppress that small feature. So for that we provided a control here, that is small feature suppression tolerance. So one can set the appropriate value, and that value will make sure that this small feature or small phase will get suppressed. So once it is suppressed, then during the meshing, that feature will not be considered and the bad quality mesh will not get generated. Similarly, we have provided one more control in the abstract model file. It's called partial sliver separation. Sometimes in the geometry, there are faces which are having high aspect ratio, and because of such faces, your mesh generated at that location is of bad quality. So in such cases, one can use this control and can set the value appropriately, and based on that value, your sliver faces will get suppressed. The mesh generated at that location would be of good quality. That's all about validating your geometry. Now let's see some details related to meshing. CAENexus offers automated meshing with least user attention, and it is integrated with CAENexus abstract model. Also, it is built upon your solid CAD model, so no CAD import or the cleanup is necessary till the time your non-manifold model is valid or you are not facing any meshing related errors. And the CAENexus, it uses a component meshing library meshing which is developed and maintained by Symmetrics. There are two ways by which you can control meshing in CAENexus. So first one is through attribute. So you can specify the attribute on abstract entities and you can control the meshing for the respective geometrical entities. Another control is the global control, which is applicable to your complete model, and that is available under view mesh control. So these are the two ways by which you can control the meshing in CAENexus. Let's now see how one can generate the meshing with some basic attributes. So first one is the mesh size. So you can give any mesh sizes as per your need. For example, let's say this is a cube structure and you want 1 mm mesh size at the top and 10 mm mesh size at the bottom, then you can do that and you will get the respective mesh. Again, if you see the cross section, then this is how the default transition would be, but you can control that transition also based on your requirement. Similarly, if your part is a cylindrical part and if you want to capture the curvature, then you can use a mesh curvature attribute with appropriate value and the curvature will get captured accordingly. So this way you can also capture the curvature based on your requirement. Let's take one more example where you want structure layers. So these are the two plates which are connected by a weld part, and on this face you want a structured layer. So in CAENexus you can just give your input in a tabular format, that is the length of your each layer, and based on the values CAENexus will generate the structure layer on the appropriate surfaces. So this way one can use the basic attributes in the CAENexus and can generate the mesh as per the requirement. Similarly, if you don't want to mesh any specific part, then that is also possible in CAENexus. So for example, if you have these two cube structure, if you want meshing for this bottom cube but don't want meshing for that upper cube, then you can use no mesh attribute and the mesh for the upper cube will not get generated. So these are some of the basic meshing attributes. Again, we have the meshing tutorials available, so I request all of you to go through that once we are done with the basic training, so that will give you an overview about all the features available in CAENexus with respect to meshing. Let's now see some of the global mesh controls. First one is controlling interior mesh size. So we have a control called as adapt element size, and if we on this, then interior mesh size is more closely matches with the specified mesh size. And if we off this setting, then interior mesh size is roughly around the specified mesh size. It will not match your mesh sizes exactly. Also, we have a setting called as set shrink mix. So if we on this setting, then the structure layers, those will get preserved. And if we keep this setting off, then the structure layers will not get preserved. One can also see the mesh statistics. So we have an option in the view tab, view mesh statistics, and one can select the appropriate quality criteria, and based on that you will see the details about element in context of that criteria. So these are some of the ways by which you can control your meshing parameters, and you can generate the mesh as per your requirement. That's all about meshing. We will now see some graphic tools. This is simulation model window. So you can see here there are three tabs: class, component, and model. Below that there is a class window where you can see all the classes. After that, there is a window which shows the relations. The center window, it shows all the attributes. Here you can see your simulation model, that is the model created after linking your abstract model file with your CAD model. Here are some of the graphics button which you can use as per your requirement. So this is a basic introduction about the simulation model window. Now, when you click on any abstract class, a respective CAD geometry will get highlighted. So in this case, if you are clicking on the closure entity, that is boundary inside, then it will highlight a face use, and the face use will be represented by an arrow, and the size of the arrow you can change it with this bottom window. And once you click on update, then the arrow size will get updated accordingly. Similarly, if you want to locate any point in your simulation model, then you can use this probe icon, and you can enter XYZ coordinate of that point, and once you click on update, you will get the location of that point in the graphical user interface. This will help you when you want to locate the meshing error location. So your log file will highlight some meshing error location, and you can use that location here in this window, and you can just see at what geometrical entity or at what location the meshing error is coming, and accordingly you can just verify the CAD at that location. You can just edit the CAD at that location. Also, you can get the information about any geometrical entity. For that, you have to just select the geometrical entity in the user interface. Then you have to go to action, get info, and select it. So this will show you the topological information about the geometrical entity which you have selected in the graphical user interface. Also, you can select any geometrical entity if you know the ID of that geometrical entity. For that, you have to go in the action, then go to select. Just select the appropriate entity, whether it's a vertex, edge, face, or region. If you are selecting face, then just put the ID of that face and just click on OK. Then the face corresponding to that ID will get highlighted in the user interface. So this way, if you know the ID of any geometrical entity, you can locate that geometrical entity in the user interface. Also, when you will select any geometrical entity, then the corresponding information, that is ID, will get highlighted at the left bottom corner. You can also hide and show the geometrical entities. So for that, you need to go in the view. Then there are two tabs, show and hide. And inside that, you can use appropriate thing and you can hide or show the geometrical entities. Pick mode is also available, so you have to go in the view tab, then select pick mode, and you can just select the appropriate entity. So pick mode allows user to select entities of specific type in graphics. You can also set the standard views. So in view tab, there's an option called as standard views, and you can just set your model in a specific standard view. Again, the shortcuts are available here on the right hand side panel. You can also see the mesh sizes on the specific geometrical entity. For that, you need to select a specific geometrical entity. After that, go in the view tab, just click on show mesh sizes, and the mesh sizes will be shown in the graphical user interface. The model tree details about all the geometric entities like volumes, your surfaces, edges and vertices. So you can see those details by selecting appropriate icons here. That's all about CAENexus basic training. Now CAENexus help documentation is available in the installation directory. So in the help folder, you will find installation guide, all of your tutorials, meshing guide and user guide. Also, if you have any question or any queries, then please feel free to contact at support@novusnexus.com and we'll get back to you accordingly. We also have a Novus Nexus support YouTube channel, and under playlist you will find all the sessions covering your FEA tutorial. So I request all of you to go through this session so that you will get more details about CAENexus workflow. So with this, we are done with our basic training. I thanks everyone and let's meet in the tutorial session. Till then, have a good day. Bye.